Hi, today's video is on how to graph an absolute value function. Now this is not how to work with absolute values in equations or even how to evaluate them. It is simply how to write an equation from the graph and how to graph them from an equation. So this looks like a piecewise function because it's broken into two different pieces. And we can write it as a piecewise function, but we can also write it as an absolute value function. Today, we will talk about how to do both. So again, we write our piecewise functions in point-slope form, which is y equals our slope m times the x variable minus an x-coordinate of a point x sub 1 plus the y-coordinate of that point y sub 1. And for absolute value functions, the point we're going to use is the vertex. So for this left part of our graph, the slope is -1 over 2. This, using our slope of -1/2 and our vertex, we can write the equation for this as -1/2 x minus our x-coordinate there is 3 plus our y-coordinate there is 2. That will be the equation for the left half of this graph, which controls our function for all x values up to +3. So x has to be less than -3, less than +3, or equal to. Now on the right-hand side of this vertex, we have a slope of +1 over 2. You'll notice that's the exact opposite slope of the left-hand side. It is not the reciprocal, but it is the opposite. 1/2 and -1/2 are opposites. Again, to write my point-slope form, I'll write down my slope, followed by x minus our x-coordinate there is 3, plus our y-coordinate is 2. And then it controls my graph for everything above x equals 3. Notice I avoid the issue of having x equal 3 more than once by just saying that this equation only works for values above 3. So to write this in a piecewise function, we'd create our little bracket to capture all of our equations, and then we just list them from left to right. This equation works for x values less than or equal to 3. And then our other equation is 1/2 x minus 3 plus 2, and that works for values greater than 3. Now you may notice that these are the same equation with opposite slopes. Now this happens because the absolute value takes our graph and it reflects all values that would be negative in this parentheses. What I mean is that this function can be written as 1/2 absolute value of x minus 3 plus 2. And any value where x is less than 3 will make the inside of this absolute value, or the inside of these parentheses, a negative number, and we want it to stay positive. That's why these look the same, but this one has that negative sign. Add in our f of x, and we have an absolute value function. You'll notice that this is very similar to this bottom equation. In fact, it's exactly the same. But we only have one absolute value equation instead of the two piecewise equations. And since we always like writing things in simplest form, this is the best we can do for that. Now, if we were going to go from an equation to a graph, I might stop off in the piecewise equation. So for example, if my equation was 2 absolute value x plus 2 minus 3, and actually let's go ahead and make that a negative 2 out front. So, comparing it to what we have up here, it looks like my absolute value equation should be my bottom equation in my piecewise function. So I'll go ahead and write that as negative 2 x plus 2 minus 3. And then the top equation should just be the same thing with the opposite slope. 2 times x plus 2 minus 3. Now, this 2 and minus 3 here tell me from my point slope form that one of my coordinates is negative 2 comma negative 3. Notice it would take a negative 2 to make minus x1 into a positive. And so let's sketch a quick graph of this function. So, negative 1, 2, 1, 2, 3. That will be our vertex point. And then it appears that, well, let's plug in a number here. If 0 plus 2 is 2, absolute value of 2 is 2, times negative 2 is negative 4, minus 3 would get me negative 7. Connecting my dots there. So it appears that, unlike before, the right-hand side of my graph is the one that's going down. Since absolute values are mirrored across their vertex, I know that the left-hand side should look almost the same. So you'll notice that we can still read our graph from left to right with our equations. We have a slope of up 2 over 1, positive 2, and a vertex of negative 2 comma negative 3. And then we have a slope of over 2 over 1 down 2 with that same vertex. It appears that this controls my graph from x's less than negative 2, and this from x's greater than or equal to negative 2. Now this little exercise lets us write a nice formula for how to graph absolute values. Given a vertex of hk and a slope of m, when I say slope, I mean the slope on both sides of the absolute value. It should be the exact same. Your equation for your absolute value should be f of x equals m times the absolute value of x minus h plus k. And if you have this equation, you can go and do your piecewise equation by matching this to the bottom equation, and then dropping whatever the sign is or changing the sign on the slope to get the top equation. So a quick recap. To write the piecewise function, do it like you would normally write a piecewise function, using point-slope form, finding the slope, but use this vertex as your x1 comma y1. You'll be able to write your piecewise function. From your piecewise function, take the bottom equation and make that your absolute value equation. Going the other direction, you'll just go backwards the entire way. So make your absolute value into your bottom equation, change the sign on your slope for the top equation, and then graph your parabola. Sorry, your absolute value equation. That is not a parabola. Those are very different. My apologies. Finally, using this little formula will help you to graph your absolute value functions. Thanks for watching.